So let's talk about credit cards. Okay, this is just going to be a really quick set of examples here. Just using the TVM solver for credit cards. Okay, so a very common credit card issue that you'll run into generally any day in life is figuring out how to buy things and which card to use to buy things and which card is a good deal. Once you start getting a job, start getting out there, you'll have lots of offers for credit cards here and there, but the important thing is to read all of the details, like our example did here, and then use your math skills to figure out which one is the best deal for you. So let's take a look at this example just to show what that can look like. Okay, so Jaden here saw a new sound system that he wanted. He saw it was on sale for $2,623.95. He doesn't have that money right now, so if he wants to buy it, he has to buy it on credit. So we're going to assume that he wants to buy it, and so he's going to borrow the money from a credit card. Not always a great idea, but we'll ignore that for a moment just to talk about the math. So he's got two options here. Option one, he has a bank credit card. So he went to his bank and they gave him a credit card with a certain limit on it. That card has an interest rate of 14.5% compounded daily. Okay, and this card has no balance on it since it's not been used before. So we don't have to worry about it having something on it already. It's free and clear. However, option two, he could apply for the store credit card. So a lot of stores nowadays have store credit cards that you apply through with them, earns you points at that store. Might be a good idea if you shop there a lot, but it looks like Jaden's just making a very large purchase here, which he might not shop there a lot. So we'll just have to use the information that's provided here and assume that they're roughly the same otherwise. So this one offers an immediate rebate, so it's money back of $100, right? So this is going to reduce that price by $100 immediately, but it has a slightly higher interest rate at 19.3% compounded daily. Okay, so Jaden knows, he's looked at his finances, and he's figured out that he can make $110 payments each month. Okay, so every month he's going to put $110 into these debts. Which card is the better option for him right now? Okay, so our criteria here, we have to talk about this a little bit in that which card is better for him. We're going to assume that means in which card do you pay less? Right, paying less overall. Okay, that's going to be our criteria for what is a better credit card right now. Since we're not talking about the other benefits in these cards, just the money, we're just going to talk about paying less overall. Okay, so I've got the solver up on the side here. Obviously, we're going to use that today. So let's start with option one. Okay, so we write down all of the information that we could possibly use here. So NI percent PV PMT. Again, you don't necessarily have to write these down. I do like to write them down just so that I don't lose track. And C per Y. Okay, now we have most of this information. We don't have the term, since we don't know how long it will take to pay back until we hit the end here. Let's fill in what we can and we'll see what's missing and what we can solve for. So first with number one, the interest is 14.5%. The present value is just the value that you are borrowing on credit. So you're borrowing it, it's coming towards you, so it's $2,623.95. The payments, we know is 110, although we're paying that back, so it's negative. For future value, we want this loan to go down to 0. Payments per year, we know that there are 12 payments per year since it's $110 each month. And finally, compounding periods per year is compounded daily. There are 365 days in a year, so 365. Okay, so we know all this information. We don't know the terms, so we can probably safely assume that what we need to calculate is the terms, so that we have all this information. So let's do that here. So question mark right there. So we're going to enter all of our information on the right here. So we've got 14.5. I'm just going to enter this information, just one moment. Okay, all the information's in there. So once we got all that information in, all we have to do is hit the solve for n button right there. So we go clicky, we get 28.34. So it's important to know what these are. The unit is going to come from our payments. right? So that's going to be 28.34 months. Okay. Okay, so now we know how long it'll take off to pay card, how long it will take to pay off card 1. So how much money was actually spent there? Well, we know that they are going to take 28.34 months, and that each month they pay $110. So if we multiply those, we should get the amount that we are actually spending in total, right? So 28.34 times 110, we get $3,117.40. Awesome. So that's card 1. That's how much we're spending with card 1. So I'm just going to shrink this for now. Oops. Just to get out of our way. Bye-bye. So we can still see the number, but it's out of our way. And now we'll do card 2 so that we can compare it. Okay, so same criteria here. We're looking for N. We now know that's what we're looking for. The I%, the present value, the payment, the FV, the future value, the payments per year, and the compounding periods per year. Okay, so quickly filling all of this in here. We've got the percent on the second card. The store card is a little bit higher. The present value. Now we know that the present value was $2,623.95, but we did get a rebate of $100, so we're going to take $100 off of that to get a new present value of $25.93.95. Okay, so similar, but a little bit lower this time. The payment's still negative $110, since we're still paying, Jaden rather is still able to pay that much. We have a future value of 0 since we want the loan to go down to 0, and the payments and compounding period are the same. Okay, so just a few modifications over on the right here. We're going to change our present value so that instead of 26.23, we have 25.93.95. Okay, that is a difference. We also have a difference in the interest, right, 19.3 instead of 14.5. But the rest of it is the same. So don't bother changing a lot of information if you're comparing very similar variables. But we can still just click the Solve for N button from here. It'll give us a slightly new number. Right, it should be fairly similar this one, but that'll give us our new N here. Right, so that'll give us our 28.92 months. Whoops, I wrote 3. Said 2, wrote 3. And that's months. Okay, so we'll notice that it's a little bit longer than card 1. So we might start making guesses about which one's the better card at this point, but we can calculate by just taking our N and multiplying it by the payments to find out how much money we actually spend in this example. Okay, so we take 28.92 and we multiply it by 110, and we get $3,181.20. Okay, so if we compare these two numbers here, this one's a little bit small. Make it a little bit bigger. Shucks. Okay. So it's $3,117.40 there. Right? So card 1 is just a little bit smaller in how much we pay than card 2. Not by much, by about $70-ish, but still a little bit better. So if Jaden was asking which is the better card, technically card number 1 is our better card, just because you spend less money. Now, credit cards have a lot more to them. There are bonuses that you get for signing up for credit cards. There are points that you earn back. You can earn cash back rewards. There might be fees involved. Maybe this is a better card overall, but it has a fee every year, which would make it not as good. Okay? The important thing is that we read the details of the contract that we're looking at. Okay? This kind of math can certainly help with figuring out which card to use, but in terms of which cards to sign up for, there are way too many out there to go through every single example, so it is worth reading that contract and doing this math.